Hello, hi everyone. Uh, Through the journey of anesthesia, I have realized कि जो inotropes होते हैं ना, that they are very confusing, especially the infusion forms of those inotropes. So ultimately, we have to know कि उनका जो एम्प्यूल का साइज है वो कितने का आता है, फिर उनका डाइल्यूशन कितना करना होता है। डाइल्यूशन कर लिया तो एक पर्टिकुलर स्ट्रेंथ जो बन गई, उस स्ट्रेंथ का पर केजी बॉडी वेट के हिसाब से अल्टीमेट डोज कितना देना है वो पता चल गया। तो इन्फ्यूजन पंप में कितना ml पर आवर पे वो चलाना है वो भी कंफ्यूजन है। सो ऑल दोज थिंग्स आई हैव टू रिमेम्बर एट वन सिंगल प्लेस, तभी वो चीज एक्चुअली में याद रहती है। तो विल बी कंपेयरिंग 5 such iron drops, which is NORAD, adrenaline, vasopressin, dopamine and dobutamine। तो यहीं से शुरू करता हूँ iron drops। अब iron drops पढ़ने का basically the easiest way is if we first write them side by side. NORAD, ADR, vasopressin, dopamine, and dobutamine. First thing is उनका ampule का size क्या क्या था। NORAD comes in an ampule of 2 ml. ADR का 1 ml का ampule आता है। vasopressin का भी 1 ml का ampule आता है। dopamine and dobutamine ये बड़े ampules, तो इनका ampule आता है 5 ml। ठीक, इन सब में से पर ml जो अमाउंट होता है is very easy to remember in the four of them except noradrenaline. Noradrenaline में per ml there is 2 mg drug which is written on the ampule, but actually that is equivalent to 1 mg. So in reality, 1 ml of NORAD contains only 1 mg of NORAD, and because the ampule size is 2 ml, so this 2 ml will lead to 2 mg drug in one ampule. So basically, in one NORAD ampule, we have 4 mg drug, which is equivalent to actually only 2 mg. Unlike this NORAD, the rest of them are very simple. In ADR, this per ml drug, this is 1 mg only. So, because the ampule is also 1 ml, the drug is 1 mg per ml, so the total drug in one ampule will be 1 mg only. Vasopressin doesn't come in mg, it comes in unit. So 1 ml of vasopressin contains 20 units. So 1 ampule or 1 ml has 20 units of vasopressin. Then comes the dopamine and dobutamine. In dopamine, it is 40 mg per ml. And because the number of letters in dobutamine is more as compared to dopamine, so this is just a way to remember that dobutamine has 50 mg per ml. So if one gets confused between dopamine and dobutamine, which has 40, which has 50, it is very simple based on the number of letters which are present in them. So this is 40 and 50. But because they come in 5 ml ampules, dopamine and dobutamine, so the total amount of drug which is present is 40 into 5, 200 mg in dopamine and 250 mg in dobutamine. Alright, so far we know what is the size of the ampules of these five, what is the per ml concentration, and finally what is the total amount of drug which is present in one ampule based on the size of the ampule. The next important thing comes is what is the per kg per minute of drug which we have to administer to a patient. For NORAD, it is 0.01 to zero point 0.4 microgram per kg per minute. For ADR, it is very similar to this only, but it is 0.05 to zero point 0.5 microgram per kg per minute. All right. With vasopressin, as we know it comes in units, so we'll not remember it per kg body weight. We'll just remember how much unit should be going per minute. So this will be 0.03 to 0.04 units per minute. This is the dosage for vasopressin. For dopamine, there are three things to remember. We have already read in physiology in our junior classes that it acts on different receptors based on different concentrations that we use. So it is D, B, and A. So at lower concentrations of 1 to 5 microgram per kg per minute, it acts at dopamine. At 5 to 10 microgram per kg per minute, it acts at beta receptors, and it acts at alpha receptor when it is more than 10 micrograms per kg per minute. This more than 10 is actually this can actually go up to 40 to 50 micrograms per kg per minute, not more than that. So if we exceed more than 10, it will actually act as at the alpha receptors, which are basically vasopressors. So dopamine at very high concentrations, more than 10 microgram per kg, act as a vasopressor more than an inotrope. So it acts as an inotrope mostly in a range of 5 to 10 microgram per kg per minute. So this was with dopamine. And the last is dobutamine. And the concentration that we use is 2 to 20 microgram per kg per minute. All right, done. So just as a quick recap for these five drugs, 0.01 to 0.04 for NORAD, 0.05 to zero point 0.5 ADR, 0.03 to 0.04 units per minute for vasopressin, 1 to 5, 5 to 10, more than 10 for dopamine, and for dovitamin it is 2 to 20 microgram per kg per minute. After having done this, when we know exactly what is the amount that we have to use for a particular weight, body weight, we have to remember at what rate we should start that drug. So that rate will depend on the ml per hour. So I have to just convert these things into ml per hour. With noradrenaline, there can be two ways of doing it. Either it can be a single strength or it can be double strength. Now, single strength doesn't mean we are using 1 ampule of NORAD. Single strength means 2 ampules of NORAD, which are diluted in a 50 ml syringe with normal saline. In a double strength syringe, we'll be using 4 ampules of NORAD, again diluting till 50 cc saline. So in single strength, we are basically using 2 ampules. Now, because we know per ampule contains 2 ml, so there will be total 4 mg drug here. Because we are using 2 ampules, there will be total 4 mg drug is present in 50 cc total MS. So we are basically using 46 ml of normal saline and adding that 4 ml of normal saline, not it, to it. So this will become 4000 micrograms divided by 50. So this will be 80. microgram per ml, which can also be changed to 0.08 mg per ml. So this is the exact concentration which is present in our single strength NORAD infusion. So if you are going to label a particular infusion, either you write a single strength, that is 2 ampoules in 50 ml, or you can actually very precisely write 0.08 mg per ml of NORAD. Similarly, if we go for double strength, so that will be very simple, 8 mg in 50 cc of normal saline. So this will obviously double, then this will be 0.16 mg per ml. So these are the two concentrations of NORAD that we have to prepare. These are the two basic concentrations of NORAD that we use practically, 0.08 mg per ml and 0.16 mg per ml. Now, what should be the rate? That is an important question. So based on this formula, 0.01 to 0.04 microgram per kg per minute. So if we calculate using that, we should ideally start a single strength NORAD with a rate of 0.05 ml per hour, and we can go up to 18 ml per hour, max to max 20 ml per hour. So if you're using single strength NORAD, you'll start with 0.5 ml per hour and go up to 20 ml per hour. But beyond that, if still the requirement is not sufficient for that particular patient, you have to switch on to a double strength NORAD. Now, what should be the ideal rate to start with double strength? That will not be 0.5. That will be starting with 1 ml per hour. And we can go up to 9 or max to max 10 ml per hour for that double strength NORAD. So these are the two rates which are important for NORAD. 0.5, starting with 0.5, going till 20, and double strength going from 1 till 10. If it gets confusing right here, how you have calculated the exact rate from where to start and where to end. So it is very easy to calculate. This 0.01 to zero 0.4, if I take an example here. Just suppose we have a 60 kg man. So if I take it right from 0.01 to zero point 0.4, zero point 0.4 mics per kg, if I multiply 0.01 with 60, and because that is per minute, to multiply again to convert into per hour. So this will be 3600 0.20, this will be 36. This is 36 microgram per hour. Now we have now what we remember is this was the strength of NORAD of single strength 0.08, which contains 80 micrograms per ml. As we have calculated from 0.01, it is 36 microgram per hour, which is almost half of 80. So this was the reason we are starting with 0.5 ml per hour of this single strength NORAD. Alright, so this is the exact mechanism how we calculate the rate from where we have to start and what should be the maximum. So this 18 or this is 20, this has come by this zero point 0.4 because this was upper limit of NORAD. So if I calculate by 0.4, this will be zero point 0.4 into 60 kg man into 60 is 36, 6 is 36 into 4, 4.4, 14400. That's it. So this will be 1440 micrograms. If I can convert it to mg, it will be 1.4 mg per hour. So if I calculate 80 into maximum 20, it will be 8 to 16, 1600 microgram per hour. So here it comes to 1600, here it comes almost 1440. Very, very similar. So these are the minimum and the maximum range, which will define what should be the minimum rate to start with and what the maximum rate to start with. Let's clear it up. So if I've removed this, you remember what is single strength, what is double strength, and what should be the minimum and maximum flow to start for NORAD. This we have done. With ADR, we remember it is 0.05 to zero point 0.5. So what should be the method to prepare it? So we'll take 5 ampule of ADR, that means 5 mg of ADR, and again dilute it to 50 cc in 50 ccms. So that will become 0.1 mg per ml. So what should be the ideal rate to start with? This will be minimum starting with 2 ml per hour. We can go up to 10 ml per hour. How the rate has come is very similar that we have calculated from NORAD only. So if we calculate by 0.05, taking an example again just to make you remember why this 2 ml per hour is the minimum rate to start. So if it is 0.05 and the person is 60 kg, it will be 5, 30, it will be 3. It will be 3 microgram. Right. So if I tell you why this 2 ml per hour is the minimum rate to start with. So if the minimum is 0.05 microgram per kg, suppose 60 kg weight, and minimum is the minute per hour will be 60. So this will be 536, 5603, 18, 180, 00, and then point 2 will be 180 microgram per hour. This should be the minimum rate to start with. So this is the concentration is 0.1 mg. What does that mean? Is around 100 mics per ml, right? So if we have a concentration which is 100 mics per ml and we have to give minimum of 180 microgram per hour, so that will come at as 1.8 ml per hour, which is very close to 2 ml per hour. That is why the minimum rate to start with in a usual adult male is 2 ml per hour, and if we will calculate it by the maximum, that is zero point 0.5, that rate will come as 10 ml per hour. This is how you calculate how much rate you should begin and end at. Let's clear this as well. Take away. So with vasopressin now, as we remember that it comes in units. So if I can convert this unit into per hour, that will be 1.8 to 2.4 units per hour. And how we dilute this vasopressin? We take 2 vials because 1 vial contains 20 units, that will be 40 units diluted in 40 ml of Venice. So this is the difference between the rest of them and vasopressin that we dilute it in 40 ml syringe. Now this after 40 ml, this will become 1 unit per ml. Now because it is 1 unit per ml, we have to start in between 1.8 to 2.4. So the rate per hour will be very similar to this. That's 0.8 to 2.4 ml per hour. This is the rate that we should start on infusion pump. So there is no point of uh, increasing vasopressin, which is 1 unit per ml, and you have increased it to 6 or 8 or 10 or 12, because the maximum you can go till is 2.4 ml per hour. This was with vasopressin. And then the last two is the dopamine and dopamine. So how do we dilute them first? First thing, one ampule as we know that this contains 200 mg and this contains 250 mg. So both of them are diluted in 50 ml of soy NS. So this will become 4 mg per ml and this will become 5 mg per ml. Perfect. Now if we calculate this will be the concentration that we actually label. Now I have to calculate what should be the dose uh, per hour. So this will be for DBA receptors that we know 1.5, 1 to 5, 5 to 10, more than 10. These were the three concentrations. So if we calculate the flow per hour, this will come as 1 to 4 ml per hour, 4 to 10 ml per hour, and more than 10 ml per hour. The method is very similar to the that we have done in ADR, NORAD, and vasopressin. Just take an example of a normal adult 60 kg male, and you'll get to know why we have selected this rate. And then the dobutamine. This has become 5 mg per ml, so the rate will be 1 ml per hour. Starting with 1 ml per hour, can go up to 15 ml per hour. This is the minimum and maximum based on this value, that is 2 and 20. Based on these minimum and maximum, this will be 1 ml per hour, starting with 1 ml per hour at a concentration of 5 mg per ml, going up to 15 ml per hour. So these are the ultimate concentrations and the method to calculate the per hour flow for these drugs. Thank you very much. I hope you understood it. I understand I've deleted the examples for them and the exact rate. So you have to remind the video, go back to the video and rewrite what I've erased. Thank you so much.